Thank you, everyone. Happy to be here today. As Benton mentioned, my name is Eric Winford. I'm the Associate Director of the University of Idaho Rangeland Center. And I'm going to talk about a study I did a couple years ago in Mink Creek outside of Pocatello on water quality. And my study co-authors are up on the screen behind me. And first, the question of well, why E. coli? And that's because it's one of the more serious water quality concerns that we have, because it poses an immediate health risk to humans. And so even if a stream isn't used for drinking water, if it's just used for recreational purposes, the Idaho Department of Environmental Quality, which is the agency in Idaho that deals with water quality issues, can ask the landowner or land manager to take steps to mitigate or deal with that E. coli contamination. And so that's what was happening here. It's an area that the Forest Service manages, and they had really high levels of E. coli. And the question was, where is the E. coli coming from, and what can they do about it? And of course, because it was a grazed area, a couple of livestock herds, cattle was one of the suspects. And so that's where we wanted to come in and say what was actually the source of this E. coli. The best way really to kind of introduce the study and the participants is to show a video that the Idaho Rangeland Resource Commission made, the Life on the Range program. So that is what I'm going to do now. Let's go. Once I figure it out.
Any kind of recreation you can think of probably happens in the Mink Creek Watershed. We have areas where people have summer homes, we have developed campgrounds, we have places where people pull their camp trailer up and camp next to streams. This is the recreational backyard for Pocatello.
In recent times, water quality sampling on the East Fork and South Fork of Mink Creek showed that the streams were not supporting beneficial uses for recreation because of high levels of E. coli bacteria. The Idaho Department of Environmental Quality sampled 7 locations on the East Fork and South Fork in 2017 and notified the Forest Service that water samples exceeded safe levels for primary and secondary contact for recreation.
When they notified us of that was very much a concern for us on the Forest Service side, because providing clean water to the American people in this area is essential to our mission. It's what we do, and we take that mission very seriously.
The Forest Service put up some warning signs about the water. But the big question was, where was the E. coli coming from? E. coli is a bacteria found in the intestines of warm-blooded animals. Was it cows, careless campers, dogs, wildlife? That's where our detective story begins. The DEQ report said that cattle were likely the primary cause for the high E. coli levels in Mink Creek, but Forest Service officials weren't sure.
We started looking back at our rangeland monitoring and figuring out that, for the most part, we have been meeting all of those best management practices for livestock grazing that would protect water quality, like stubble height standards and like utilization and bank stability. We knew we didn't have all the information to solve this problem. So we reached out to the University of Idaho and said, help.
Cattle research specialist Jim Sprinkle and Eric Winford from the U of I Rangeland Center came to the next meeting with key stakeholders, including the City of Pocatello, DEQ, and local ranchers.
I raised the question, well, I think it would be good for us to see who the major contributor is. So how do we do that? Well, we do that with DNA. We got a little bit of pushback on that. Some of the people were concerned that it'd even be possible to do that. But Eric Winford assured people there that he believed that the University of Idaho had that capability and could do those tests.
Indeed, the notion of being able to identify the actual sources of E. coli through DNA testing is a fairly new thing.
And so Jim and I were kind of on the same mindset of like, we needed to find out what's the source of this E. coli. We had kind of, we shared some papers, and we knew that there were other researchers that found that dogs had contributed to E. coli before, geese had contributed to E. coli in streams as well. So we knew there were other possible suspects out there.
To do the DNA research, the team needed $25,000 to cover costs. The Forest Service's Region 4 office in Ogden stepped up to fund the study. Eric Winford reached out to Alan Colick, director of the Idaho Water Research Institute at U of I. Colick found a graduate student to help with water sampling and tapped Jane Lucas, a postdoc PhD in the Department of Soils and Water Systems, to do the DNA analysis.
It was actually a very fortuitous series of events, because when Eric got in touch with me, at the time I had a student, a graduate student, who was looking for a project. He wanted to do something that was both environmental, but was using kind of cutting-edge molecular biological techniques. So this project relative to source tracking worked out perfectly for him.
The U of I research crew ventured into the Mink Creek area in the summer of 2019 to collect more water samples.
And in the study, we wanted to look at how livestock E. coli levels were in the stream prior to, during, and following grazing. We also wanted to do the same with humans, because there's a lot of human recreation on the stream, and we wanted to check that before and after major holidays.
They resampled at the 7 DEQ sites, and they added an additional 7 sites to collect more data. Idaho State University provided lab space for the grad student Nick Vishwanath to do an initial analysis of the water data. The DNA samples had to be stored at 80 degrees below zero. Jane Lucas explains how they determine the source of E. coli through DNA testing.
And it really allows you to take a bunch of DNA and look for specific markers. And what's really nice about this project is that we were looking for human markers and cattle markers. And there are specific bacteria that live in the digestive tracts of humans and of cattle that are just always present. That really allows us to kind of assign where this bacteria is coming from.
Okay. Back here to the microphone. Okay, so that was a snippet of a video. It's on the Idaho Rangeland Resource Commission page under Life of Range project. So check it out for the full video if you'd like to see it. A brief review, and then I'll get into some more results. So this is a map of the Mink Creek Watershed. Kind of look into the northeast. We had sampled 14 sites total, 7 sites that the DEQ had sampled previously and 7 more. The whole watershed is about 30,000 acres. It's mostly managed by the Forest Service, but there's some private land and some state land in there as well. There are 2 cattle herds that graze during the summer. One's about 350 head, the other's close to 500 head. And there's a lot of dispersed recreation, some dispersed camping, just a handful of trails heads and picnic sites in the watershed. And so repeated the sampling, 14 sites from May to October, so before the grazing season and most of the big holidays to well after the grazing season. And before and after all the holidays, the Forest Service was the funder. In addition to E. coli sampling and getting water for the DNA analysis, we did also some regular water quality measurements like temperature and dissolved oxygen. This is showing the DEQ or the E. coli sampling method, which is kind of following the standard procedure. And then the DNA analysis, we extracted the water and then sent it in for sampling that Dr. Jane Lucas was talking about. And we were looking really for 2, whether it was human or cattle related DNA. The third category that we'll be talking about here in a minute, that's just anything else that wasn't either human or cattle. We kind of use the symbol of this coyote to show that, but it could have been any source of other animal or dog. All right. So the results, we had 98 total samples, and 36 samples over the course of our sampling period exceeded the IDEQ standard. And the IDEQ standard is 126 organisms per 100 milliliters. The two biggest sampling dates were July 8th and September 5th, so right after the major holiday weekends. Sites 1 and 2 had the greatest exceedances over the course of the summer. So this graph showing the different sites, all of them had an exceedance at one point, and then the sampling dates. May 29th didn't have any exceedances, which isn't unexpected because it was cooler and it was kind of a cold, wet spring. And then the two big days were July 8th and September 5th. And then it dropped off again afterwards. So the big reveal is the source of bacteria. And in this graph on the right here, 59% of the sites that had an exceedance, that was related to humans. And then about 29% was this other category. So it could have been a dog, could have been wildlife. And then 6% of sites had DNA related to cattle. And then another 6% had both a human and a cattle marker in them. And this shows the breakdown by date on the left. And all the cattle exceedances occurred on July 8th. And we'll get into that a little bit more, but we think that's because it was just a hot weekend. And then the cattle experienced the high heat load and shedded more E. coli. So I'm going to talk a little bit about some specific sites and specific dates. And this is kind of the map of the watershed, the Mink Creek Watershed, where we have the different sampling sites laid out in the green numbers. And the arrows show the direction of that the cattle herds were moving. So one herd started up here, kind of this is the top of the watershed at Catch, in site number 1 in the beginning of June. And the other herd started down here in Lead Draw, a little lower down in June. And then that herd moved up and the other herd moved down. And this was May 29th, so no exceedances this date, right? It was a cool, wet spring. And we know that a lot of E. coli is not going to be showing up in the water because of the high water levels and just because it's very cold. The symbols on the right there just show the different sort of where the source of the E. coli came from. And so I'm going to jump to July 28th, a really busy slide. But this had 10 exceedances throughout the watershed that day. So almost 3/4 of the sites had an exceedance. And you can see which ones had a cow source, were a couple on this watershed right here where the cows had been moved into recently. And then this one by Lead Draw. And so that's showing that the cows, where the cows had just moved into, there was an exceedance, there was some E. coli exceedances, but the majority of that was the exceedances were from humans and then this other source of wildlife, even downstream of where cows had been. So moving on, another day, midsummer, August 8th, the cows were still in the watershed, but they had moved on. They had moved up higher. And we didn't have any cattle exceedances that date. It was all related to humans and wildlife. September 5th, another big holiday weekend. And you can see all the sites that had seen some human related E. coli. So the big takeaways from that are timing related to water levels, how much water is in the stream, and then temperatures, and where the cattle were moving and related to that. So moving on to a couple specific sites. And so this one's the site number 1. It's that red star up there in the upper corner. And this graph shows the red line of where that's the exceedance level for the Idaho Department of Environmental Quality. That's 126, right? The gray box in the center is when the cows were in the watershed. And the green boxes are the levels of E. coli that we found, and the lower little symbols determine show what was the source of that E. coli. And so when you see that gray box, there is an exceedance when the cows are in the area, but it wasn't related to cows or to humans. So this next slide, this one was a repeat of the DEQ site, and you can see the maximum amount that the DEQ found was 2,000, over 2,000 organisms, and that's 20 times the level that their regulatory level set at. So well over the regulatory limit. The DEQ definitely needed to say something and do something about this, but when they were looking at it, and they could see that this, in the gray box, when there was cows in there, there were high levels of E. coli, but the DNA analysis shows that it was only one time was related to cattle DNA. The rest were related to humans or other sources of wildlife. Next slide, very similar results. When there were cows in the area, there was some exceedances, but it wasn't related to cattle. So that's summertime. People are camping. There's a wildlife in the area. That's where the E. coli was coming from. Pretty much the same thing here, and I'm just kind of reiterating this in order to show, kind of to make one point really, is that correlation is not causation. Even though that you're seeing high E. coli levels when cows are present, and then the E. coli levels are dropping off after the cows are removed, doesn't tell the whole story, right? You can't make a management plan just off that. You need to learn a little bit more about where that E. coli is coming from, and that's where our study was really important for the Forest Service, because they could be like, okay, well, there was some exceedance from cows on July 8th, very hot day. But after that, it was mostly related to humans and other sources. This site I just wanted to highlight because there was no grazing here. It was a DEQ site, and it's outside the grazing area, fenced off, but it also had an exceedance that was related to humans. Jumping across to the other side of the watershed, similar story over here with the gray box and the levels of exceedance, with only one spot related to cows, and most of them related to humans. Another site, same watershed. We really wanted to oversample this particular portion because it had a lot of issues when DEQ sampled it. And we wanted to figure out, well, what was going on? What was the real issue here? It's a site that's very popular with the recreationists. They party there. It's also a site where cattle were dropped off in the summer. And our study showed that it was mostly wildlife was the issue. Another one here, this was a popular recreation site. And so you can see after the cows are been removed, there's still high levels of E. coli showing up that are related to humans. And same thing with this slide. All right. So before I kind of move on into what are some management options for producers, I wanted to finish up the story a little bit. With this information, the Forest Service was able to kind of target some management actions. They went after a couple of sites that were particularly problematic and installed some off-stream water. And one of the recreational sites that I showed you, they installed, redid the parking area, installed some fences to keep the humans more than the cows out of the stream, and installed more of a recreation presence in that area. So more Forest Service staff officers were showing up, trying to do a better job with signing and getting people to recognize that it's public land and they should treat it with respect. So a little bit of summary here real fast. So in this study, our highest levels of E. coli were on July 8th. And we know that water levels were dropping and temperatures are rising. And so that increases E. coli. Then higher temps can also increase E. coli levels coming from cows. Like cows will shed more E. coli when they're hot. And that's found in a couple of different studies that they show that midsummer is a high time for cows to shed E. coli. And they also shed E. coli when they're interacting with other cows. And cows will shed less on rangelands when compared to irrigated sites. But that when there's surface water present, like if cows are drinking from a stream rather than a trough or a tank, then they're more likely to be E. coli in the stream. And cattle are likely spending more time by the water as temperatures increase. And we'll look at that some more here. So this is showing temperature and humidity in Pocatello during the study site. And this was July 7th, right before we sampled. And it's showing that kind of in the middle part of the day, the temperature and humidity reached a point when cattle were likely to experience a mild heat load. And so what are cows going to do when they get hot? They're going to lie down, they're going to rest, they're going to go to shade, they're going to get water. And so that's what we think was one of the culprits and one of the causes for the July 8th levels. Again, this is another piece that my colleague Jim Sprinkle is working on. This is showing grazing time during the day. So grazing time on the left axis there, and time of day on the bottom of a cow during 2 different times of the year. The dashed line is the spring when it's cool and mild, and they're grazing quite a bit, right, throughout the day. But during the late summer when it's hot, that grazing time decreases, and that's because they're experiencing that heat load, and so they're going to go lie down. What can you do? Short-term and long-term options. Some short-term options are herding and moving the cows to uplands areas, maybe with salts and supplements, reduce the congregation of cattle, and reduce cattle stress through low stress handling techniques as you move your cows around. Long-term, perhaps some off-stream water, upland shade cloths or shelters, improve trails to uplands to move the cows up there more efficiently, or change pasture rotation, which is one thing that the operators in this study did. They were able to move the cows, start them lower when it was cooler, and then move them higher when it got hot. And then genetics, which is something Dr. Sprinkle has been working on, and I'll spend a couple of slides talking about that next. So this is, again, grazing time per day of 2 cows. This time one cow in the green line is the efficient cow, and the other is a purple line is the inefficient cow. And the cows were classified as efficient or inefficient using a residual feed intake study at the Nancy M. Cummings Center outside of Salmon. And it's showing during the same day that the efficient cow is grazing more during the afternoon when it's hot than the inefficient cow. And we attribute that to the fact that the inefficient cow has a bigger gastrointestinal tract. They're going to generate more metabolic heat, and then they're going to spend more time lying down. And this is showing the same thing, just as a map where the green dots are that efficient cow and where they're at spending the time during the day, and the red dots are the inefficient cow. And the inefficient cow is hanging out by this riparian area down here, not really moving that much, while the efficient cow is kind of going up in the hillsides and the northwest facing slopes in this area. And through this work, Dr. Sprinkle has been able to find some genetic markers for that efficient cow, for that hill climber. And he hopes to kind of start presenting on that more and publishing on that more and getting that information out for people. So a brief little video now to finish this up.
Well, it's been a great opportunity for us. That's the mission of Extension, is to make science help answer some of the questions and problems. And if we can do that, if we can help provide some answers, then we feel like we're doing our job. And I really got to hand it to the Forest Service here. They handled this the right way. I've been in other places in other states where it's not been that way, but rather than just using a big regulatory hammer, they wanted to look for solutions and the answers to questions. And so that makes it pretty easy to find out answers when you got a willing partner like that.
Well, thanks for the time. We have time for a couple of questions in the room or online.
What are your conclusions on managing the cattle? Just changing pastures at the right time, or any other?
If you have the option, that's a good one. Off-stream water too. It really depends on what your options are. Off-stream water, if you have the option to herd the cows more away from the stream when they might be loafing down there, that seemed to. I think the operators, as I mentioned in our study, changing pasture was the easiest one for them, and they worked with the Forest Service to install off-stream water in a couple of spots, and that seemed to work out pretty well. Yeah.
On that topic too,
Yeah.
This great study, by the way, and I was curious on Mink Creek. Is there other off-stream or water supply in that drainage, or is it really they just go down and water supply is only from the stream?
Yeah, the water was only from the stream, but once we got the study done, the Forest Service was able to install a couple of off-stream water sites in a couple of the problem areas that they had identified, and they did also install some fence, but between the two, that seemed to make a big difference for that site.
My assumption is the DEQ levels are based on the amount of E. coli and their effects on humans. Do E. coli have effects on cows? Detrimental effects?
The question is, do E. coli have effects on cows and detrimental effects? I'm not a veterinary health, so I'm going to have to. I don't actually know that one very well.
Pathogenic ones to do. Didn't have access, you can test.
So that the answer from our good doctor was, it depends. But possibly, yes.
We had Ken Tate from BC Davis up in Washington State helping us out with some significant water quality conflicts a little while back. But he said one of the reasons why E. coli is measured is because it's cheap and easy to sample and measure for. That usually what they're concerned about with other pathogens where E. coli is indicated of the presence of fecal material in the water, but it's usually other stuff that is more pathogenic, at least to humans, that is the main concern. So E. coli is an improvement over generic fecal coliforms, but it's still a depend on itself. Usually, it's usually other stuff that is real.
Thanks, Doug. Yeah, that's great.
Very much.
Yeah, thank you.
Appreciate it.